So let's just like say please see on the screen. So we have a positive sign convention is satisfied when the current enters through the positive terminal of our element, and the P is equal to plus or positive V, or is about each time the current goes through the component. If the current enters through the negative side, so there will be something like this. So we can see here there's a two case of element with absorbing power 12 watts. Look at that. It goes through here, goes through here. So this is the positive side. Positive side. So this is the power is plus. You don't have to say plus. V is 4 volt. Time current is 3 amps. So it's 12 or 12 watts. 12 watts. Okay, it's the same. So look at that. It's the same, right? It goes through the current is the same, right? The current goes through here is a positive or negative. So it's the same. Okay? It's the same. It's the same. So this is a figure 1.9. Figure 1.9. So we are talking about next one. So power and energy. Why there is the same? Okay, so here there will be a negative because the power convention is like something like this. If we have the current, look at that. This is minus, is positive. So we go through here this side to this side. So why is negative? Because you can see from negative. This is I is here. So it's already V is equal to 1 and current. Current, you can see from here. There's another way to see this. For example, the first one, of course, this is you call this 3. Or you can see from, normally we say, like I use this one. Again, I call out this our lovely friend, when we talk about normally, we say this is the current. Why? This is go from, right? From positive to the negative side. But here, you can see from this side, it's kind of different. It is go from this way to this way. Look at that. You don't go here to here, just like say here. So from negative to positive, so the current should be what? Negative. So you can also say the voltage times the current is equal to minus 12. Perhaps here got called a little bit confused, but that's fine. That's fine. Just remember this one. This is a component. But look at that. It has a similar thing like this one, right? Minus, positive. Current go this way. This is the same. Minus, the positive go this one. And this is the normal one. Normal one, it consumes or absorbs 吸收 energy. So this is from positive. So here, one thing is very, if here is, we say that there is a P, I use a ray. This is P. For example, this is a lamp. There is a P. This is a battery. Because about the conservation of energy. So the P, battery, plus P lamp should be equal to big 0. I speak English first because according to the law of conservation of the energy, inside a closed circuit, we provide the energy, and the component who absorb the energy. All the things should be equal, or should be everything put it together should be a big 0. So 在 closed circuit 的这个东西的话，吸收跟提供它的所有的功率应该是压大。当然，你可以把就是说那种提供的一个部分跟吸收的一个部分放在等号的两边是可行的，是可行的，是可行。可是因为它有正负号，所以你可以把它放到等号里边，可是它在什么是0，这后面我们会稍微提一下啊。可是 but here is what we say is the same. So a little bit confused, but that's fine. That's fine. Okay, so here again, look at that. In fact, lower conservation of energy must be obeyed in any electric circuit. For this reason, the algebraic sum of the power in a circuit at any moment of time must be equal to 0. Okay, 0. It's just like the one I'm talking about here. Just I wrote here. I forgot. Yes, I have coded, so that's fine. So this should be a power and energy. Of course, this is energy is a capacity of do work measured in joule. This is sometimes, for example, this is watt hours. They say, okay, watt, the energy is the integral for the power time the time. So the power is equal to VI. So everything together. There's an example, very simple here. So we have here. So example 1.4, energy source force are constant current 2 amps for 10 seconds to flow through a light bulb. If 2.3 kilojoule is given off in the form of light heat energy, calculate the voltage drop. This is simple, right? Because the total charge is here, right? Because you can use this one or use the other way around. It's the same. But right now we just use this one. The total energy here is 20 volts. Because this is, just remember the equation here before. Just try to do, just remember the equation before. Because the light, if we say that the charge here is the current time, it should be from here. I is equal to delta Q over delta T, but it is the same, so we can divide it from here. So this I is current. Just remember where this come from. This come from previous. I forgot which equation, but because we have a current and we have time, we know the total charge goes through this lamp is 20 coulombs, and with the voltage drop is here, 23 joule. Actually, you can use another way around. For example, you say that this is the energy we are talking about, right? So just remember the power is equal to what? dW, dt. This is another way around. It's much easier. So how many work does it do here? It's 2.3 times 10 equals 3, right? How many seconds? 10 seconds, right? So what does it mean? This is 2.3, this is 230 watts. So power is equal to what? This is power, 功率, power. Power is equal to what? V times I, right? I, how much? 2. So V, so right now you can see how much here. So V is equal to 115. It's much easier, right? So all go to the same. Just one if you want to test your knowledge, you just say, okay, I will definitely go to here. But you still have to remember this equation. There's no doubt. But of course, if you go the other way around, yes, that's fine. But everything should be the same. 150 volts. Okay? It should be the same. It should be the same. No matter how do you deal with this kind of situation, but, it should be the same. Okay, let's now go to next one. Okay, so this is simple. This is simple. It's very, very simple. I just, my God. Find the power delivered to the element T3 millisecond if the current enter the positive. Look at enter the positive terminal. So that means that the power should be positive, not the negative. Our voltage is here. I is equal to and the voltage is V is equal to 3 times current. V is equal to this one. It's a very simple. It's very simple. I think I leave this one to you. It's just so simple. The voltage is here, right? So the power is V equal to I, right? Because this is very simple. This is simple because here it's only simple calculation. Simple calculation. Here is I is here because I is equal to 5 cosine 60 pi t. Right. So of course. So the voltage is here. So you time these two together, to the 3 millisecond is here. Blah here. Use your calculator, blah blah blah. So, 53.8. And the other find the voltage is the power is that. It say here, this is the differential. Differential. Of course, this one differential is 60 plus 300. I know that. Is 65. Yes. So this is minus 900, and the calculation 3 millisecond. 3 millisecond. This should be very, very simple. Very simple. This has simple calculation. Very simple calculation. Very, very, very simple. Okay, next one. Example. How much energy? Oh, this is 2 hours. This is hour. This is watt hours. So this is the same. P is equal to I. We just repeat. Just repeat. It doesn't really matter. Just repeat. Just repeat. I leave this one to you. The circuit element. There are two types of current. These are passive and active elements. So the most important active elements are voltage and current source that generally deliver power to the circuit connect to them. There are two kinds of source. Look at that here. This is I say that this is I think that's most important section in this chapter, because normally we didn't, when we are talking about when in a senior high school or in junior high school, we don't talk about specific this one, passive and the active, especially this one. Passive is what? We are talking about three things: resistor, capacitor, inductor, 电阻、电容、电感。Call it passive, 被动式元件。Okay, active. Here we're talking about battery or power source, but in electric circuit in this course we are talking about two special things. Not two special things. Just we didn't see it before when we are talking in senior high school or junior high school. One is called independent. Remember, independent and dependent. Dependent 独立的，或是不独立的。中文不知道翻成什么，Okay, here, there's a definition. An ideal independent source is an active element that provides a specified voltage or current that is completely independent of other circuit elements. Just say it. Already said it's just independent because it's just okay. I want to provide 5 volts. I want to provide 2 watt, 2 current. No matter what, no matter the connected circuit, do whatever you want. I always provide 5 volts. I always provide 2 amps. This is called independent source. Okay, independent source. Okay, so it's simple. It's simple. It's not that. But just remember these two. Okay, dependent, independent. And here, yeah, the first one. Here we come. This is a circuit. Okay. When you see this one, the first impression. Here. Here we have a positive, we have a negative, and I just tell you this is a power source, and I just ask you one very simple thing. Intuitively, 直觉上 it is a voltage, provide voltage or provide current， 它提供电流还是电压？猜一下，不要管，就是直觉啊，觉得是它提供电流的，请举手。提供电流一个两个没有关系，那其余都是电压咯。到底是电流还是电压？它提供嘛，就是说那个菱形的那个，有人两个是提供电流啊？为什么提供电流？他可能看到，老师这个有一个 I， 所以它提供电流。那你们都觉得按这边这些小女生们，你们觉得它提供电流还是电压？都很安静 ，very silent。第一个，看下面的 statement。Okay, the source on the right-hand side is a current-controlled voltage source. So it is a voltage source or current source. 哇，英文如果不好，我打这么简单。它是不是一个 voltage source？ 它提供了电压。对 ，power source 只有两种，在我们这个课里面只有两种，一种提供电流，一种提供电压。好，提供电压。那这个有正负极，你就把它假设想想看，就好像一个电池，电池它出去稳定，电池它大部分我们电子提供的 AA 都会提供1.5伏特嘛，它们是我试着不管我外面的电流多大，我就希望我从两端的话，我的电压是固定的1.5伏特。这个也是一样，它有一个正负极，你就看到会有这个正负极的，就是提供电压。OK， 容易吧？等一下一个箭头的，你要给你做一个 comparison， you will see the difference between current source and the voltage source. Okay, here. So here, right now we have something like this. So yes. Yes. So this is what we call it. It is. Please notice that. Because we say this is, of course, this is a voltage source. Look here, it is already said. This is a voltage source. But there is one thing to be sure. This is current control. These are two gentlemen say this is a current source. He say because I think he see the eye. Yes, they are right too. They are right because this is a current. Because the voltage, if we put a voltage, 我们放一个三用电表去量量看。它的确是被另外一边的大小所控制，它提供的错，它的一量的它的电压的大小就10乘以 I， 这个 I 在哪里？各位有没有看到这边有个 I？ 有没有看到？它这个提供的电压的大小就是10倍的这边的电流，就是它如果1安培，它提供10伏特，它如果是0.5安培，它乘以10就是提供5伏特。对不对？我懂你。这边如果是0.5安培，所以它这个10乘以0.5，所以它就提供5伏特的电压。所以它是什么 ？Current control voltage source， 它是电流控制的电压源。所以机头，Chapter 2， 你们教到第2章了吗？还没哈。陈慧芬老师的课，哈哈。 God bless you guys。就说他很强悍哦。排列组合，你有电压跟电流，所以说它就2×2，它就有4种可能的组合，所以它有4种。等一下你就会看到什么 CCC， 什么 CCC。V 什么 CC 什么，这里给大家看啊，什么 VCVS 等一下我们就可以看到哈。好，我们看下一页哈 ，Next page we talking about here. Oh my God， calculate the power supply by absorb by each component in figure. 哈哈 ，this one, the first thing we are talking about, we see in this figure is here. Remember this one. If we have if it's a circuit, it's a circle one, it's independent. That's okay. I just say here, but later on we will describe this more closely. Because in this example, we're still talking about the power. We didn't say specific. So, oh, what's this one? This is called what? Because this one is controlled by what? 0.2. This is current. So this is current control. Current control. Control. It should be 1L only. And what did this provide? This is a current source. So we call this one CCCS. So the abbreviation is CCCS. I think the later in this one will, and this one, this is CCCS, right? How about the previous one? Here, I don't want to change this. I just go look at that. This is the body, so this is the CCDS. So I want to say, oh, what's this power source? What is called? What is abbreviation? What is name? You should tell me this is current control voltage source. And this one is current control current source. 电流控制的电流源，电流控制的电流源。Okay, and there is a lot of things going on in this one. Yes. Here. So I should copy this one, and then I should copy this one to later on. Yes, copy. So you. Oh my God. So you can see from here. Okay, so we apply right now. We will try to do the solution here. Do the solution. We will apply for the sign convention for power shown in the figure 0.8, 9. I think this is. Oh no, that's fine. For P, the 5 amps current is out of the positive terminal. Look at that here. Look at that. Go inside here, right? And then go outside from here. So what's this one? What's the power consumed by this one? Look at that. It go into the positive and then go outside from the negative side. So of course this power should be power. Why it is negative? Oh, sorry. We're talking about here. Sorry, I forgot. This one is called power 1 amp. This one, P1, you can see here. Right? P1. Because it goes from negative to positive side. The current is go this way. Look at that. The same line. 各位很重要，我用中文讲一次，等一下再用英文讲一次。各位这边你看哈，你看黑板不要管我哈。这边同一条线里面的 current 没有说在同一条线怎么这边是正极，那边是负极，不可能的，你知道吗？各位，这一条线你看到这边有没有这个5安培？看看这里，所以这5安培，这个也是5安培，这个地方走的都是5安培，而且都是这个 direction， 不会这个突然颠倒了 ，OK？ 懂我意思吗？好，我再说一次，好，我再说一次，好，各位 ，the same branch, same branch, this one, look at that. Here we are talking about here. We have a current go this side, so this is 5 off. Of course, this is 5 off, and this is 5 off. The direction should follow this one. Okay, so it is like this. So remember. So of course, from this, so we know here the 5 volts go here 5 volts, 5 amps. Sorry, 5 amps. So here, because if from negative side to positive side, so why? So this is a 12 volts, and but with a negative. 为什么这是负？是因为由负往正。各位，所有的东西这样你要记住，这样这个是正常的。好 ，current 一定从正往负走嘛。我刚才不是用我们的最喜欢的那一个有没有？我们今天 current 我们在老师在说最简单的图，我们 current 是不是都是从这个 I 为什么是这样？因为我电流从这边出来嘛，从这边出来我电流对不对？然后经过这个，然后再回到我的负极嘛。可是我们现在不只是这样，我们要考虑到 we have to consider this battery, and for this battery we treat it like an element， 我们就把它当作是一个 element， 当一个元件啊，所以它从负往正啊，那个怎么见啊？由负往正，所以这个为什么 current 是负5伏特就在这里，有没有 ？EC into the negative terminal， 所以 why this is minus 5 amps。So this is minus 100 watts. It is supply power, supply power. Because this is negative, so it is supply power. Power 2 and power 3 is easy. 啊？不是，它不是电子，不要管那么多。现在电流，我们电子流全部都丢到垃圾桶里面去。先不要想那么多，什么电子流、电流，你会跟电流搞在一起。你现在就只有电流。一个东西就好了。我们现在都只考电流跟电压，电流跟电压都有可能有正有负。那我现在就要告诉你，现在由这些题目中，你开始去搞清楚，说它怎么去定义。以这本书为例，这个是大家都要用这种定义正跟负，知道吗？流进一个，各位你看哈，我再讲一次哈。一个 component， 它这个电流已经是固定的，它已经跟你讲，对不对？电流是这个方向，所以5伏特它就从正，如果是正5伏特，正流这样子乖乖的5伏特从电流流正到负进去，它这个电流对它而言就是正流。可是你怎么可能这种东西？你看，可以想要说，我正常的话是不是我水往高处流，水往低处流？对不起。要往高处爬，对不对？我正常的时候，我跳起来的时候，我会不会往上飞？我一定往下跳，是不是由正往负走，对不对？这是正的，我消耗我的动能，跳到地下，这样了不了解？可是这个像无敌铁金刚一样，它竟然没事会由里面的电流从负到正，是不是不太正常？为什么？它supply power，它里面有化学能。提供了电流，所以它电流它是被推动，把它推到更高的程度，就像我按电梯把从1楼到5楼，从负到正。可是这样的东西怎么表示？老师这提供它竟然是负的 ，sorry， 它就是这样搞，所以到最后它整体加起来会变成0。你算多了你就知道，算多了你就知道，这是一种 training 这是一种 training， 这跟不在脑筋里面要能够去算。这是最难的地方，我觉得看到到最后的时候，你们看到那种后面在计算一些网络分析的时候，都是正跟负在搞来搞去都死定了所以没有关系反正今天就搞，反正就这样子 ，OK， 好，再来， 这里各位你可以看到P2 and P3 the current of flow into the positive terminal element in each case. Look at that, flow into the positive terminal of the element. So you can see P2 here, here is P2. So this is 5. This is, look at that. This is 5. This is 6. So this absorb power because it is plus. So this is all absorb power. So it consume 消耗能量So always say consume. Remember this word consume. Consume. Okay. Okay. I recorded everything I said. I do on the screen, but to be honest, the effect of the recording is not very good. Okay, because there is a distance between me and this computer. There's a recording device, so it is not very good. But that's fine. If you guys want to see, I will put it later on in the iLearning. Perhaps it can remind you something. Also, solution here again. I should record this one. I should copy this one. Copy. Okay, excellent. Okay, so we assign the comment. So here, what is it? These two is the same. Should be P4. Oh, it's strange. There's two things is the same. That's fine. Doesn't really matter. So solution P4. P4 is here, right? So P4. That's one thing is that right now we have how many components here? Is it 1 or 2 or 3 or 4? And then you can see here that we say that okay, there's for P4 we should. The most important is P4. 1, 2, 3 is very easy because you already defined. There's a current go here, But how about this one? Of course, we know the current in this case is a 0.2 times I. I is here. Look at that. I is 5. So it is said in here 0.2. Look at that. 0.2. Right, 0.2 times 5. 5 is because of this one. But why it is negative? Look at that. There is a statement. For P4, we should know that the voltage is 8 volts. Why? What is 8 volts? The first thing is that why is 8 volts? Because this is a parallel connection. There is something here connect together, here connect together. There's an 8 volts. Of course, if we put it here, we know this is the same. 各位避免国中数学国中物理所以因为我们知道这个是巴伏特，这里有没有这个 component？ 所以这边当然，因为它前面它中间有没有任何的东西？没有，所以这一个旁边应该是巴伏特。这要知道，这没什么难的这is easy positive top, and the same as the voltage P3 since both passive elements and depending source are connected to the same terminal. Okay, remember the voltage always measured across an element in circuit. Since the current from out of the positive, 各位你可以注意看，它这个你看，它从这边出来，它是正，这是负，所以呢，它一样是负的，就好像这个一样嘛。刚才从这边5伏特之于这一个 power source is negative, it's not positive. Again, this one, the same. This is a negative, okay? So this is minus 8. So we should observe the 20 volts independent voltage source and the 0.2 dependent current source are supplying power to the rest of the network. While the passive elements, look at that, if they put 1, 2, 3, 4 all together, it's equal to big 零蛋哦。In agreement with equation 1.8, the total power supply equal to the total power. 好，各位，这个为什么要加？它就是要这边要加起来，一定要有正有负，才能变成零。好，重点在于这里。好 ，the important thing is here. 啊 ，the important thing is here. Okay. And here. Oh, that's okay. Today, I think we put a lot of things already. Just think about something. Think about something. Here, yeah. So let me